manual. This is a little bit manual, but if you want a different data set, right? Okay, if you did this, you get one data set, right? So if you want a few data set, what you might want to do is to say something like set 1 equal to this, right? Okay. What I mean is you can play around with this to generate the data set, but every time you play around, it's just gonna overwrite the name. Okay. So if you got something you like and you want to save it, you would have to save it in separate names. So you might do this. So set 1 is equal to that. Okay. And then you play with it, and then you get another one, and then you say set 2 or something. Okay. I'm sure there's more automatic way of doing this, but this is so that you can have different set to play with. Okay. And so what you should do for your I would like to see something like this. Let's say you copy this picture. This is probably a little bit much, but this, okay, and say something like this, and then you write a note down below it, something plain text, because this data set has whatever too little of the second population, the clustering is just gonna show only one. Sorry, zoom. Nothing. What I mean is this. Okay. Okay. Welcome to the second half of this class. By now you should have this program, right? That generate data set. Okay. And this is the parameter for generating this. Now, once you set the you see that once you set the parameter, it automatically generates a data set and save it as XY4 clusters. I just named it like that. Okay. So what if you like this data set already and you want to save it for later? You just say, you play with it. You say, oh, I want to play with this. Okay. So data set 1 equal to data and the XY4 cluster, right? So you get this, right? So what it effectively is copy saves a copy of that data set that you generate. So let's say you try something else, okay? And you try something else, you try something else, you try something else, you try something else. And hey, I want to play with this too. So you say data set number 2 is equal to that. So now you have 2 data sets, right? Inherently they're kind of generated from the same program, but it's actually 2 different data sets because you actually set them separately. Okay. So is data set 1 equal to data set 2? No, of course not. Okay. And when you do the clustering, it's going to be very different. So what I would like you to hand in at the end of the class, I'll give you some time to play with it. So don't worry about doing it right now. I'll try to in about 15 minutes. Maybe I'll give you half an hour after class. So what you do is this. You can copy this as a picture, copy, Control C, whatever. And you can say something like this, and you can just write in the text. Okay. Because the second or third lump are fused together, when I run the find cluster, end up with only one cluster. Okay. So for example, if you, let's say I move everything together, let's move everything together. Yeah. I'm going to bet that it's not going to find anything. It's just going to find one cluster. This is my bet. Okay. So I'm going to say, so I'm happy with this, right? I'm going to save it as my data set 3 is equal to this. And let's see, find cluster. Okay. Data set 3, right? Now, I don't even have to look at the partition data. I just say, what's the length of this? That's just going to give me the number of cluster that it finds. What do you think I'm going to get? Probably going to get 1. True. Oh. Oh, so maybe there's some feature in there. Okay. So something like this. I think the reason is because this little guy. So let's okay. And now I'm being a little bit mean. So okay, now I'm pretty sure if I did this, it's gonna have just one lump. Yeah, I'm pretty sure. Okay. So let's say data 4 and length of this data 4 equal to 2. Okay. Well, we have to believe in the algorithm. Oh, okay. I can see why. Actually, there's some when I generated too many points, I masked myself that I didn't notice this. But we can actually move everything back to what's W1? What's W1? I'm trying to think. It shouldn't. Okay. Okay. So it's still able to distinguish a little bit of clustering. What tends to happen is that as long as it's unimodal, it would like to have one. Okay. But if it's bimodal, even just a little bit, maybe the algorithm detects. So that's good. Okay. So this is something that, you can play around with. So you would say something like, based on this, obviously there are 4 classes or whatever. Okay. And in fact, you get 4 classes. Okay. Now, who wants to play with real data? Okay, let's start again. Sorry. ตรงนี้แล้วกันนะก๊อฟเดี๋ยวอัด14:49นะ Okay,ครับ welcome back to the second half of the 5th class of Big Data Analytics. So in the first half, we play with the data set that we generated in 2 dimensions. Okay, so the idea is we know how the data set is generated, and we can see how the data can be the individual lumps, individual cluster can be far apart or close apart, and we can play you can experiment with it, see what happened to the results. Okay, so what you should do is just get this guy, get this data set, right? And that's the name when you run it, right? Just save it as something to play with and then play around with it, save it in another name, and then play around with the clustering. Okay. So that's supposed to give you a little bit of intuition of how data clustering works. But let's now turn to real data. So let's try the real data. Okay, so this is demonstration on generated 2 data. So now I'm going to do 2 things. I'm going to take a data set and walk you through the steps of doing cluster analysis and then visualization of the result. And then I'm going to show you as well that in the end, when professional data scientists, they'll do this, they'll try a few configuration. Once they're happy with it, they would encapsulate the result as a tool, as sort of like an app, so to speak, in your language. Okay, so all these tools, all these techniques, we play with it, we visualize it, we play with it, blah, blah, blah. But at the end of the day, it's a journey from data to the end analysis. And once we've done the middle part, the approach, we're happy with the approach. Then we encapsulate the beginning to the end as some kind of quote unquote function library. And then we hand it over to our clients or user, whatever. Cool. That's called encapsulating. So it's going to look like the steps will be like this. Okay, this is the second half of the class. First, we'll import the data, right? Second, we'll pre-process, maybe visualize the data a little bit to get an idea. I already have an idea what it looks like, but you do it with every single data set. Then we run the cluster analysis, right? We run the cluster analysis, and then we visualize the result. Now, let's say that there are different approach, or let's say that your user, your client wants a k-means, and has set on 5 cluster. Well, what you might do is to say, well, how about 4 cluster, 3 cluster? You can try different things. Whatever it is, the final product, you end up thinking that this is a sort of presentation you want. Then you go through the whole step 1, 2, 3, 4, but you encapsulate it as a single pipeline. Okay, that's what a professional would do. Okay, so hopefully we'll get to this 5th step, but basically the 5th step is just gonna copy step from here, but wrapped everything together. So now I want you to go to the data set, that I asked you to download. Okay, let's say you downloaded it, right? So what's the data set? Let me go to the class note. This one, right? Okay, so what's an Excel? Excel is a spreadsheet, right? So how do I get a particular number? Now, with an array, a rectangular array, the first index you go down is the row. The second index you go across is the column, correct? But with Excel, you actually have different sheets. So the way this is done by convention, obviously it makes sense, right? Instead of having 2 index, we have 3 indices. Index 1 refer to the first sheet. Index 2 refer to the second sheet. Index 3 to the 3rd, 4th, 5th, and 6th, right? And then let's say today we are going to, I think here. Yeah. So let me see what I wanted. Yeah. Okay. Notice my data table. Okay. Type this in. Type this in your notebook. Okay, where's your note? Where's your line? Okay, type this in. Okay, now let's see what it does. Okay, let's see what it does. Okay. Type this in first, so that this is where you set your working environment. Okay, let me add that as well. Again, in reality, depending on how you project, you can create environment, but this is just a simple thing, right? So put everything together. So set your notebook in the same directory. Set directory that it's going to refer to as the notebook directory. Okay. See, what this function does is say, where am I? Notebook directory say, where am I? Where am I? Okay. Set directory, work there. Okay. So I want to work where I am. That's what it means. Okay. Now I can actually set, target directory to be some kind of data repository. But in this case, you're going to save your notebook code and the data set here in the same directory, just to make life easy. Where am I? Work there. Okay. Now this thing, again, it's blue, right? So it's not assigned yet. I haven't pressed enter, so it doesn't. It's a free variable. It is equal to import and the name of this file. Okay. So if I did this, what I'm going to do is import the whole Excel. Now, just to make life easier, because I don't want the whole Excel, I just want the second sheet. Okay. Now there's obviously clever way of accessing with title and name and whatnot. But in this class, just make it easy. What I want to do is, what do I want? I want the second sheet. That's number 2. So let's go to second sheet. All right. I want to go to the third row. I don't know why I put third row. I could have just said second row, but I don't know. Okay. For some reason, I have third row. So second row until the end. Second row until the end. Right. And then, yeah, I don't know why I have 3, but I'll just leave it at 3. I don't know why it's weird. 2. Okay. And then how many columns do I want? I want all the columns. Okay. That's all it means. Okay. Second sheet, second row on, semicolon. If I want second row to the 5th row, what do I do? Second row to the 5th row. Okay. But if I don't put the end, it just go all the way to the end. Now, the end happened to be 242. Okay. But I don't need to do that. So I can put 242. Okay. All mean all columns. So what this is going to import is a data table. That table is going to cover from here. Oh, I know why I put 3. Okay. So this is going to be from here all the way down, blah, blah, blah. Now, don't worry about this, but this data set has 4 keys. That's why it's a little bit complicated. When you look at this paper that I was telling you earlier, it manages all the 4 keys. But this data set has 4 keys because it has the country code, it has a continent, it has a location, and it has a date. Okay. So what I want to do is just forget about all this. Okay. Forget about all this just to make life easy. Okay. I download this data set. Okay. That's the data table. Now I pre-pick for you. The following column: 3, 4, 5, 9, 10, 13. Again, that simply means corresponding to this thing. 3 is the blah, 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 you know. So it's all this. Okay. Right. And something like that. So let's say, you know, you don't have to do all this. Let's say for some reason I pick that. Okay. 13, 15, 16. It could be some number, something about the okay. Oh, I know. My very bad, my apology. The reason I have 3 is because, okay, never mind, ignore me. Okay, this is good. Okay, so the column index is this. So this would be like big file. I import part of it. I'm going to work on even smaller part of it. That's what I want to do to say in this 3 step. So take this data table, okay? See? Sorry. Oh, this is just the take element, right? When you press square twice, it's going to say take the element. Basically, okay. Remember, everything is function, right? You have to give the argument in the bracket. But if the argument is a position, then you put another bracket in there. So 2 brackets together just makes it look like that. Okay. That's all it means. Okay. In fact, if you look at the line here, it's just 2 brackets. Okay. Right. So let's see if that's done. Okay, let's start again. Start again. Supervised machine learning. Let's go to the real data. Okay. Okay. There. Okay. Again, this is the name of the file. I'm importing the whole Excel. I'm going to the second sheet. I'm going for the third row down. Actually, I could have gone the second row down. I think it's a typo. Okay. So third row down, all the columns. Second sheet, third row down, all the columns. Okay. The column that I'm going to pick is not the whole table. I have the whole table. It's too long. I decided I'm just going to work on a few. Basically, what it means is that this is the raw data set. This stage here is the data set you're going to work with. But for this analysis, I'm just going to look at this variable. Okay. There are actually like 60 variables that the data sets keep. So I'm just going to look at these. Okay. Now, the variable name is the first line. So these are the variable name. Total death, total case, total death, blah, 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 blah. See that? Right? Total death, total case, total blah, 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 total death case per million. Yeah, I want to move this one up actually. Okay, fine, never mind. Yeah. Let me sheet a little bit. Okay, let me sheet a little bit. Okay, I changed my mind. Now type all this in. I just make all this assignment. The reason I put bracket dimensions around it is to give in one step. I want to know how many row, how many columns. Yep. Sorry? You cannot what? Oh, tell you what. Copy the whole thing. Copy the whole thing like this. Okay. It's the same thing. Just set directory. Yes, you could. Oh. Okay. It would. This is the result. This is like the column name is in the file. Yeah, it's already been set. Yeah, so this is an output. This is an output. Okay, I just want to check. Okay. Now, again, the reason I did this in 3 steps is I want you to get the feeling of what it's like to work in real life. In real life, this is your database. This will be your database access. Okay, database access. You would access it. You would get some component of it, like this. This will be like component of a database. But you're not working on the entire database. You're just working on part of it. Okay. In fact, you know, I could have put this over here actually, and that would have been in 1 step. But I want to emphasize that this is how you work. Okay. Again, I'm simulating real life, but it's not that realistic. Okay. So this here is accessing a database. This here is extracting from the database. So you can imagine that accessing database is very expensive. You pay money for it. You will always get as much as you think you're going to use. But for this case, I'm just going to play with this. But in the future, I might play with something else. So I don't want to just download this. So these 2 steps are actually very big step in real life. Okay, I'm just pretending. Okay, so you pay for this. This is very expensive. You pay for it. You get as much as your storage can handle. You maybe download it on your thing. And then today, this is today, I'm going to work with parameter variable 3, 4, 5, 6, 7, whatever. Okay, these are what I'm working with. But tomorrow I might work on something else. Okay, so this is extraction. So column index are the thing I'm interested in. The variable data is what I have. So now I have 2 things. I have names and I have numbers. Again, in a more elegant way, in a professional sense, I'm actually going to have what's called a dictionary. I point to the name, it gives the number. But today, Very simple, very flat. So this is a list of name. Okay. Okay. So var name has total cases per million, total death per million, reproduction rate. That's reproduction of the COVID. Okay. The R number you guys hear from the news. That's the R number, reproduction rate. Total vaccination per 100, people vaccinated per 100, stringency index. That means how stringent it is, your country is at the lockdown. Population density, median age 70 or older, GDP per capita, cardiovascular death rate, diabetics, hospital beds, life expectancy, human development index. So these are kind of like multidimensional stats of a country or a continent or the whole world that measures incidence of COVID as well as related health indicator. So diabetes, for example, right? Okay, so you should get this number. If you did exactly, just key in, right? Do you get this? So these are the names, right? Now, how many variable am I looking at? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm looking at 15 variables. How many locations have I got? 241. Now, actually, that's not the number of countries. It's number of country plus region, because in this COVID data, they also keep the data for the whole world, for Asia, for Oceanic Island. Okay, so I'm just saying right now you have the stats, and then you have another file that looks like this, and it has all the location 1, 2, 241, right? And this here is total case per million. This is human development index, and this is all numbers. Okay, this guy is called var name, and this guy is called var data. Okay, okay, so that's what this means. Okay, yep. That is that is a step here, pre-processing. Okay, missing values. Okay, missing value. So this is actually just this is scoping. This is called scoping. Okay, you actually can get the scope and you end up with something that's nonsense. Okay, you haven't done anything, you haven't looked at the data yet, so you don't know if it's all nonsense. So that's the next step. Okay, now let me erase that. Okay, in fact, this next step is going to make sure that your data is valid. Unfortunately, first of all, it's part of life that you're going to have to do data cleaning. It's also something that's not really taught per se. It's best when you run into your data and you work with it. But the general principle is you look at the empty field, okay? And you ask yourself, what should you fill it with? Sometimes you fill it with 0. Sometimes you fill it with the median of everybody else. Sometimes you fill it with means of everybody else. Sometimes there's so many missing, like, you have 1,000 data point, 900 of them is missing. You decide that variable is not worth it. Okay. Now, in this case, I think these all have numbers, so you don't have to worry about that. But anyway, so let's visualize that. Okay. Now, this function here, okay, okay, that means yeah, because I changed a little bit. Sorry, I cheated. Okay, just copy it like this. I'll copy it like this. Go to the line group and go to the last version. Okay, just copy the whole thing. Okay. Yeah, this is very painful sometimes, nitty gritty. So it's not the fun part. Okay. Well, here's you beginning to look at what you want to do. Okay. The data filling, let's say we don't have to do that because it's filled. Okay. So I don't have to what's called impute. Now, what do I have to do? I haven't told you this, but in clustering analysis, if you're going to do distance-based clustering or whatever, chances are all the dimensions have to be on the same scale, right? Right? So if one scale is meters, the other one scale is centimeters, the number is so big, it's so different. So what I want to do is standardize. Okay. Now watch this. Now I'm being a little bit ambitious here. I don't know. You can watch my hand. Okay. Watch this. This is the data, right? This is the data set. Okay. So this is X1. This is X2. This is X3, right? What I want to do is, watch my hand. I want to take all this, subtract by the means, and divide by standard deviation of that column. Okay? That's called standardization. That's called standardization. Okay? So what I want to do is standardize this guy. Now, the data is row, column, row, column. So if I standardize all row, what's going to happen? It's going to be nonsense, right? So the first thing I did was I transposed the data. Yeah, so it looks like this. Right? So it's a list, right? It's a list of this, right? Then I say standardize, apply to all of this. So it's going to take this thing, standardize automatically. This is a built-in function. Again, in the old days, you would have to calculate the mean, subtract, calculate the standard deviation, divide, but now it's so obvious. Okay. So it's going to standardize all this, standardize all this, standardize all this, standardize it. Good. Now I want subtract the means, divide by standard deviation. So the reason I did this was because so that each data variable will have the mean 0, standard deviation of 1. So to make this comparable size, basically. Yeah. So you can imagine if this is 1,000, this is like 5 or 2 or 3, right? When you measure the distance, it's going to give a lot of weight to this guy because the number is big. I don't want any variable to dominate other variable. So I want quote unquote size of variable. Now, I don't do that with size of variable. I do it with size of data. Okay. So the data of the first variable would be normalized or standardized, sorry. So I take all the country, total case per million, divide, subtract by the mean of every country and divide by standard deviation. I do the same thing with death per million, reproduction rate, vaccination. I did everything. So now, even though the names have meanings, the values are dimensionless. It's something that's 0, 1. Okay. So I make now. So once I did this, I have to turn it back, right? So that's the transpose here. So see that? Original var data. Okay, original variable data. I transpose it, put on the side. I map the standardized. Then I transpose it back and I give it back the same name. Yes, 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 yes. Sir. This is the visualization. Now, so I want to visualize. Right? Basically, yeah. Basically, this is kind of like original data. This is the transpose, the standardized. Again, there's a kind of transpose here because I don't want to go sideways, but that's just formatting. The point is, okay, let's go. So take this away. Okay. So what I did was I standardized it. So that's the whole of my pre-processing. Okay. For this job, that's all I do. Okay. The other job, they need something else. Okay. Now you can see that this is total cases per millions. This is the original histogram, right? It's in thousands, right? Death per million is in thousands, in hundreds, right? So this is big number. When you go to reproduction rate, that's small number, something between 0 and 1, right? So if I'm going to use this as 1 dimension, two dimension, 3 dimension, it's going to give a lot of weight to that, right? I don't want that. I don't want that. I want them to have same weighting. So I standardize. So now everything is, if you take this histogram and you measure the mean, it's going to be mean 0. If you take the standard deviation, it's going to be 1. Now it's not normal because the data is not normal. So you don't get something like this. But you can see that everybody is centered around 0 all the way down. Right? Okay. So now this code gives you the visualization. So human development index, most countries in the middle, some country positive, negative, hospital beds per 1,000. Again, original dimension you can read here, right? If you want something like GDP per capita, you have to look at the axis here. But the normal standardized value is here. This is what I'm going to use. Okay, I'm just showing it here, but I'm never going to use it again. I'm just going to use the right. Okay, right. Okay, so basically it's scaling. That's what it does. It's standardized scaling. Yeah, this is quite yeah, come talk to me after class. But standardization is a fairly standard procedure. Okay, if you click this, by the way, if you click, and this is very clever, F2, standardization, if you say standardize something, it's going to subtract the mean, divide by standard deviation. But because data scientists also want to do something else, and they have done it 1,000 times in a high level language, they make room for this. So you can actually put F1 and F2. In other words, the function that you want to subtract by. So actually, you don't have to subtract by mean, divide by standard deviation. You can subtract by median, divide by interquartile range. Okay, it's that flexible. Okay, so if I put the list and I put in the word median here, and I put interquartile here, it's not going to subtract the mean. It's going to take the median of that, subtract it. It's not going to divide by standard deviation. It's going to divide by interquartile range. Okay. So it's very flexible, but most of the time, just simple standardized will do. Okay, fine. So we standardize the data. Again, this is the name. This is the data I'm going to play with. Okay. Now I'm going to run cluster algorithm. Okay. Again, we can find cluster using find cluster, right? We can. Okay. I have a, maybe it's a bad habit. I can write things in multiple lines, but I tend to put things in one line because the code's complicated now. I want to find cluster. I want to use length on the result of that to find out how many member each. Then I use length on that to find out how many cluster. Then I add timing just because sometimes I want to see how long it takes my computer, because I have cheap computer, expensive computer, very expensive computer. Sometimes I want to compare, like one thing takes 5 seconds, one thing takes 10 minutes, whatever. So find cluster, yeah, find cluster, name it cluster. Find cluster, name it cluster. So it's going to be set, offset, offset. Yeah, so this is cluster, right? Right? What happens if I apply length to each set? It's going to count how many member, right? How many? How many? How many? How many? Right? And if I apply the length of the whole this, it's going to be 1, 2, 3, 4 cluster, say. So in one step, I maybe I shouldn't do this in a, yeah, it's textbook. I should do one. Sorry, bad habit. But anyway, 4 steps. in one line. So what it means is shift enter 1.7 1.89 seconds. So 1.89 seconds, okay, and it has two clusters. So let's okay. So what was it? Num cluster? Two num cluster, right? And then cluster size 10 and 231. Okay. So out of 241 countries or location, there are two clusters. One cluster has 10 members. The other one are similar. So basically, most countries are alike. Most countries are alike. By the way, I did this. Remember, my son, you know, who's in high school, doing a paper on this, and ran this. I think like maybe last year or early this year. I don't remember. Came with a lot of cluster, different cluster, using all the data. But after so many years, most countries kind of like follow the same profile, apparently. Okay, it used to be very different from different countries, but I think in the end, this everybody's bad. You can't interpret it yet. You can't interpret it because right now you don't see it. So hold on a second. Hold on a second. You see it. 10 countries. So what it means is that instead of looking at X and Y coordinate, I look at these coordinates. Okay? I look at 15 coordinates. Okay. So instead of looking X and Y, I look at 1, 2, 3, 4, 5. I look at 15 dimension. In 15 dimension, every country is a dot in that 15 dimension. And I say, go, stay. Where find your spot? It turns out that in that 15 dimension, 231 lumps together. And 10 countries, not. Okay, so 2 lumps, big lump, small lump. This is not always the case. Okay, this is not always the case. When you're doing marketing analysis, you know what you hope for? You hope for big, medium, small, tiny. So you can say big, you use like a mass marketing campaign. A tiny, if it's high wealth, you use a special whatever, you know. Okay. When you do anomaly analysis, anomaly detection, you know what you hope for? You hope for one very big and one very small, maybe 2 very small, because those are suspicious. Okay. So you don't really necessarily want to have 5 clusters of the same size. That's not the objective. Okay. That's not the objective. So we haven't visualized. We're going to visualize. Okay. So basically, I ran this, right? I ran this. Now, so I run this. I got 2 clusters. How am I going to visualize it? Well, I can't visualize 231 countries, right? I also can't visualize even 10 countries. But you can think of definitely going to have these 2 little lumps going to have different profile, right? Why don't I just look at representation of each lump? And what's a natural way of doing representation of each lump? Just take the average of within the group. So if I have you guys clustered by height and weight, and there are 2 groups, okay? Maybe tall and heavy and short and light, right? In order to visualize these 2, what am I going to do? I'm just going to take the average height and average weight of one cluster, and I'm going to show it against average height, average weight of the other cluster. Okay. The average within cluster is given a special name, centroid, cluster centroid. Okay, basically cluster means. Okay, right? So that's the name. Yeah, the name kind of stuck. You can say cluster means, but for some reason the name centroid stuck. So how do I do that? Well, here I just use mean, right? Cluster centroid is equal to means of each cluster, right? So let's do that. There you go. This is what you want to visualize. Okay, you can't visualize yet, but you will want to visualize this. Why? Because this is the average death per million standardized of the first group. This average death per million of the second group. So right away, this has no meaning because you standardize, right? You lost the meaning of human being. But you know that the first group is lower than the second group, right? I can bet. Second group is probably, I don't know, United States or something, okay? Because they have a lot. Well, maybe not, because they have high population. Yeah, some country can be very small and have high death rate, even though because they have small population like Belgium or something like that. Not too many people have the cases, but it's a small country. Anyway, so I don't want to preempt, but the point is that this is the average of the first variable standardized within the first group. And the first group has what, 243? I don't remember the first is small or the first is large, but anyway, two of them. Okay, let's see what happened. So how do I visualize this? Obviously, it's it's 10 dimension, right? 10 dimension is still big. So the way I'm going to, okay. Note, I make a note here that it's better to actually do this. Okay, create a function. Let me just do this. Okay, this is what I told you normally I would do. Okay, and it's very powerful. Actually, in this case, it say that it used DB scan. See? It likes DB scan. Not only me. Everybody likes DB scan. Okay, so let's say I have this. I have this. Okay. Now, what's the next step? I'm going to visualize. Now, I'm going to do a few things, okay? I'm going to calculate min-max of the value. Just do that. I'll tell you why later, okay? And I'm going to calculate the thickness of relative cluster size. Oops. Okay. This thickness is for graphic. What I want to do, and you see, what I want to do is to say, wait a minute, there's what, 241 divided into 240, 231, and 10, right? So the relative size is 231 to 10. So that's the number. Yeah, that's 231 to 10. So this is thickness. Why am I going to specify this? Because I'm going to use this to draw. Okay, this is the size of the paintbrush. But the paintbrush is going to have the thickness proportional to number of countries. That's what it means. Okay. So cluster size divided by total cluster, get the value, and then I make it a little bit. Okay. Now this is the radial axis plot. The radial axis plot function, and voila. That's the function. Okay. Now, not only did I put radial axis plot, I actually have manipulate. Okay. What it means is that, remember the min max? That's the range of this thing. Okay. So that plots nicely. The thickness, that's, remember, 0.09, 0.009 versus 0.0004. That's the thickness of that line. Okay. So what it means is that, holy cow, there are 10 countries that have very high population density and have very high hospital beds. And actually, let me see the death rate. Total case is actually minimum. Oh, so the opposite case. This would be like maybe Scandinavian or something like that. Okay. Not very sparsely populated, has Bates for everyone. Very dense, something like that. Okay. Now, like I told you, when I was doing this with my son in high school, using all the data, we had more variation, more variety. But actually, you know what? Okay, so this is how the whole thing comes down to, right? So what I'm going to do is encapsulate everything. And I want to do this quickly to give you guys time to play with. Okay. So the way we encapsulate thing is, well, you guess it's functional programming, right? You encapsulate everything in a function. So I'm going to define a function. This function called prepare data to cluster. All it does is to say, give me the data table, give me the column index, right? So now we have flexibility. This is what I mean by deliverable. Let's say in my data analysis, I'm doing this for a client. I say I play with this parameter, I play with that variable, this and that, blah, blah, blah. But at the end of the day, they want flexibility. Okay, I can tell them that the factors that distinguishes countries are beds per millions and human development index. Eventually, they're gonna say, well, what about GDP per county or something like this, some number. So they always want flexibility over and above what you deliver. So I give them flexibility, right? Instead of just specifying 3, 5, 7, 8, 9, 12, 13, 15, or whatever that I chose earlier, they can do whatever they want. This variable name data is not standardized, so that's original data. Data standardized, okay? The variable name, all this that used to be global variable, I put in method so that it's compact, it's in here, okay? And it doesn't bother anyone, right? So I did all this, blah, 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 blah. And I return variable name, variable not standardized, and variable standardized. So basically the 3 columns that you saw earlier, right? So if I type in the names, if I take the histogram and put in the grid form, there's a function called grid. If you noticed earlier, it just make it in a block. Okay, it's going to plot these 3 things. Okay, so that takes care of the standardization and you know, giving it as a name or something. Okay, so from now on, you don't have other data set, right? You don't have other variable, but the flexibility is there. Okay, let me erase that. Okay, right. So you can call that if you like. Now, what else do you have to define? So this is a function, right? I haven't pressed enter, so let me do control enter. Shift enter. Okay. So now this function is working. Okay. What else do I have to do? I have to define the function to encapsulate cluster analysis. So that's the define cluster. Now, to be honest with you, for this data set, I wanted to try k-means as well. In this case, I think k-means sometimes works better, even though it's not as contiguous like a DB scan. So I make 2 versions. One is to use specifically k-means. Okay. So what I mean is this. It's a bit hard to see. Okay. In cluster analysis, I separate into density based and distance based, right? In distance based, the k-means one is special because it requires you to specify the number of cluster beforehand. So from function definition perspective, the one that's unique is the k-means. Okay. The other one, I just say, oh, use Gaussian mixture. Oh, use DB scan. And it's going to find the use hierarchical. Okay. So again, theoretically, the difference is between distance based and density based. But in terms of application function call, the distance based has a special guy called k-means that asks you to specify the numbers. That's why I make it 2 separate. Okay. In this case, you can choose the data. Okay, so presumably it's already been standardized. Now, again, okay, I can ask for automatic or a client. Let's say a client is like you, have seen DB scan successful 1,000 times. So loves DB scan. Okay, he doesn't want to believe anything. He just wants DB scan. So what I'm going to do, I'm going to put method as an option. Default : is automatic. But if the guy wants to put DB scan, Gaussian mixture, contracted neighborhood, I don't care. Okay, just go at it. So that's why in my find cluster here, I don't put just the data itself, I put method. So this method, if the guy doesn't specify, it's automatic. If he specify, it's something else. For k-means, on the other hand, the parameter is here. So notice I use the same word. I intentionally do this. Look at this, guys. The number of cluster here is the length after you've done the cluster analysis, right? Just like before. But for k-means, number of cluster is a parameter. It's a little bit of subtlety there. Okay, there's a difference. I call DB scan. I measure how many partitioning it came with. If it gave me 5, then you say DB scan gave me 5 cluster. But with k-means, I have to tell the algorithm, I want 5, I want 6, I want 7. So it doesn't come out as a result. It goes in. So the same word have different purpose. Okay. Now I return this in the same format. So I put in the data. I put in the column I want to play with. I standardize it. I stick in the standardization. I send it to the method. In general, I can choose any method over here. But if I happen to like k-means, I have to specify it over here just because it's special. Okay. So I make it 2. What's it going to do? It's going to calculate cluster like before. It's going to tell you what the cluster sizes are relatively. It's going to give you number of cluster, and it's going to give you cluster centroid. So these are exactly the lines above. This is what so in professional life, you play with the data, you try this, you try function, you this, you transform. Once you are happy, you encapsulate. This is what I mean by encapsulate. Okay. So in reality, I'm going to send this to my client. I'm not going to send the above. Above is sort of like my scratch note. I try this, I try that, I try this, I try that. Okay. So all I'm delivering are the blues. When I deliver the operating code to the client, I just give the blue. Okay. There is this function that takes the data, specify which column I want to play with, standardize it. I standardize it and I find cluster, and then I visualize. So that, oh, sorry. Shift enter. That. Okay, fine. Okay, so visualization, same function as before. Same function as before, right? Except now the thickness used to be calculated by itself somewhere up there. Now I put in the module. So it's here. The thickness is proportional to cluster size, right? The 0.1 number is, because you can try it first. It's going to be very big paintbrush. So 0.1, just make it manageable. With centroid, line thickness. Okay. Now in this case, I actually have another special function. I say, you can see the whole 2 cluster centroid together, or you can view them individually. And that's here. Okay. Which centroid? Now, the number of cluster gives you, let's say the example, let's say it has 5 centroid. 5 centroid. Range of number 5 is a function that's going to give you range from 1 to 5, 1, 2, 3, 4, 5, right? I prepend it with the word all. So now I can select all, I can select 1, I can select 2, 3, 4, 5. You guys get that? Okay. The number of cluster, let's say, came up to 5. So if I want the first cluster, I have to specify I want to view 1. I want the second cluster, I want to specify, I have to view 2. If I want to view all, I have to use the word all. So what I do is I create the number 1, 2, 3, 4, 5, prepend it with the word all, and ask, which centroid do I want to watch? Hopefully all this works. Okay. So now, okay, these are module of the pipeline. Remember, data to standardize, standardize to cluster, cluster to visualize. Now, this I would actually send to the client because that's the functionality they want. They can actually use this on its own. But if they are really lazy or they want to just sort of like beginning to end, I'm going to create another encapsulation that takes 1, 2, 3 in one go. Does that make sense? So now I have to do 2 ways again because you know the K-means is special. So this is it. Yeah. So this function is very simple. It takes 3 functions. 1, 2, 3. Apply them in sequence. This is what I mean by data analytics pipeline. And that's what you're going to build for your project. Okay. So you're going to be learning different techniques, choose different data. You're going to try this, you're going to try that, you're going to try clustering, you're going to try machine learning, feed forward. I don't care. Whole bunch of things. But at the end of the day, there's going to be a journey from data all the way to presentation. Let's say presentation, mostly in the form of visualization. Okay, I don't want just tables of number. So think of it as raw data at one end, visualize graphics, interactive visualization at the other end. In the middle here are different functions that encapsulate the steps. And then there's a big function that wraps 3 functions, 4 functions, 5, basically 3, 4 functions. Okay, prepare the data, run the analysis, present the visualization. Okay. So let's say I have this. How does it work? Well, this is what it do. Okay, let's go one at a time. I specify first, like in the beginning, right? I want to, where do I want to work? This is redundant because I did this already. But I'm going to say, this is my data table. This is my column index. I define this first so that I would pass it to the function. Okay. Now there are 2 functions here because one function is this, the other function is this. So if you remember, sorry, not function, parameter. Where is this? Import data. Okay. So this is assuming we've done everything. This is how your user would use it, right? Actually, I need this. Basically this. Make sure I've got everything typed the same way. Yeah, it looks the same. So it's exactly the same as before. Good, good, good. Okay. Now, I'm going to run both. And you'd be surprised that they would look very different because K-mean is very peculiar. Well, not peculiar, but okay. This is using automatic. Okay, just now we use the whole set now. We use the whole set. So this is where everybody's at. Okay. It actually, for this run clustering, you get 4 centroid for this data set. 1, that's everybody. That's huge. Okay. 2, so there's some countries, actually, there's some country that extreme poverty. Okay, nothing to do with COVID, but the poverty index is through the roof. Vaccination, forget it. So this is a group of country that when you take the average vaccination rate, average poverty scoring, it's a very sad place to be. Okay, this is one group of country. This is another group of country. This group of country is quite rich, actually. It's got beds for everyone. Beds for everyone. Very old. I'm pretty sure Japan's in here. Very old, well taken care of. Lots of hospital bed, lots of old people, no poverty. I'm pretty sure Japan's in here. Okay. Now, how would I know? I won't, because I didn't keep the original fine cluster. If I did, then I can say, oh, where does Japan belong? Okay. Okay, let's look at another group. This one, oh, this country is kind of, it's not poor, but very old, has a lot of heart disease, has a lot of case, has a lot of death. America, I'm pretty sure it's America. In the, okay, we don't know because I took out the name. No, yeah, this is the fourth cluster. So it's an average of the fourth cluster. This is the best way, and I'm saying this, you don't have to believe me, but in my project, I have had to learn not just the science of data analytics, but the art of presentation or presenting the result so that people understand. Centroid with thickness proportional to cluster size is probably the most intuitive. When I use this, people understand. So I would imagine that's why I use this. Yeah. That kind of visualization you can do, like, I don't know, other plots, pie chart. You guys know about pie chart, right? You can do all kind of stuff, right? Well, I chose this because in my experience, these are the best. And so I'm recommending to you, if you don't like them, find your own way. But this is my recommendation. Now, obviously, this is kind of like automatic scaling. Okay, so this is kind of like, so if I want everybody to be on the scale, I put this as true, fix the scale. See? So if you fix the scale, everybody looks like this. So there's a majority of big number of country. There's some few country here and there. Now, you guys want to see K-means? K-means is going to give you, because I require that 5, sorry. Blue is the big population. So most countries are here. No wonder they're kind of like in the middle of everywhere. This is not always the case, guys. Don't expect to see a perfect round, okay? But this happened to be, this population dominates. So average everything. It's basically all the countries, most of the country. These are the exceptional country, okay? Now, again, you don't necessarily want this, okay? And when I did this with my kid, I didn't get this dominance because I was basing on earlier data set. This is February of this year. So most countries are like together now, I guess. Like Thailand used to be an excellent performer, but eventually we got the second wave, got the third wave, and we just as bad. Well, not just as bad, still pretty bad. Not that good. Used to be very, very proud that we were the second country after China to get it, and still we managed very low rate. And then the second wave comes, and the third wave. Oh boy. This is actually more interesting. Okay. Now, what this means is that because, and K means it's a little bit of, you kind of force to have distinct centroids. Okay. Think about it. Instead of allowing you to hold each other's hand, if I say, you, how many hands can you hold? You keep holding, you ending up with half the room. Now, in the beginning, I say, no, forget it. I don't allow anybody to hold his hand. I'm just going to sprinkle center, 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 center. Immediately, that forces you guys to partition into center, right? So it's no surprise that you get more evenly. Now, I don't know if this analysis is more interesting, but this is everyone. This is everyone. This is group 1. Okay. By the way, if I don't keep the scale, it's gonna be more dramatic. But okay, so this is a country of heart disease and poverty. Okay, heart disease. Again, not a nice place to be. This is lots of hand washing facility. Apparently, I didn't know I have this variable in there. Hand washing facilities, guys. Okay, lots of population, fully vaccinated, life expectancy. I don't know. I don't know. Maybe Japan. Okay, 3. Old. Lots of bed, lots of death. Not too many places to wash your hand. Yeah. Good point. Yeah. You guys hear that? Did you guys hear that? Why would you have age 65 and together? They kind of give you the same information. Okay. Yeah. Your point exactly. I probably can just use one. However, is it harmful? The reason it's harmful is because effectively these two gets 2 weights and they're measuring the same thing. But it's not as harmful as putting them together in a regression equation. Well, so I don't know if you know about regression equation. If you put highly correlated, it gets multicollinearity. It's terrible. This is not as harmful, but effectively, it gives a lot of weight to this. You're right. It's enough. Yeah. It's not harmful because it's not giving like multicollinearity, and that gives a fixed what's called a fitting error or something like that. It's terrible. Here, what it means is that you implicitly pay a lot of attention. Okay, that's all. That's all. Okay, because they're measuring essentially the same thing. Yeah, you're right. It's a good point. Good point. In fact, I'm going to change my example. Okay. Yeah, very good point. Very good point indeed. Now, holy cow. I meant to give you guys 20 minutes. How about you guys give yourself 20 minutes to turn in the homework? So what I want you to do, yeah, is I'm going to pretend that I give this and this and this. I give you the blues, all the blues. So you don't have to write anything. Okay, where was that? Take away. What? Take away. Okay. Yeah. Right. So if you have this, right, you can, well, I might as well make life even easier. Just give you an example of the first case. Okay. Now this is insulting your intelligence a little bit, but I want you to now don't think of yourself as data scientist. Think of you as user. Let's say you get this product. What do you play with? What you play with are basically the column index. Okay. Now what you would do is to keep yourself reminded of what the original index is. You can say data table first row or something. Okay. So that's going to give you, for example, you were saying earlier, was it 25 and 26? Okay. So based on your recommendation, I'm going to get rid of, well, I think total debt. I don't know why to have total debt. I thought I did away with total debt. Anyway, I don't know. Okay, play with it. Okay. Once you have this, you can play with it. So I save this. Sorry, guys. You know what we can do? We can sort of like raise your hand. Okay, so let me save this as takeaway. Takeaway. Where's the takeaway? Wow. Yeah, takeaway. Save. Okay, so use this one instead of the previous. Okay, so play with this. Okay, and guys, be here on time. For those of you who came late, I've decided we're going to take proper toilet break. Nobody's just gonna walk in and out randomly. Okay, so at maybe 13:15, yeah, take a break, back, and then I'm going to give you like 15 to 20 minutes at the end of the class, hopefully before 4 o'clock, for you to play with this. And I will try to make all the homeworks in class homework. Okay? That way, you get to immediately ask. Okay. So that. So no more, just getting up and down randomly, and be here on time. Okay,ครับ. I'll see you next week. Now, next week, we are going to go to dimensionality reduction. So we won't go into supervised learning just yet, but that's okay. I think supervised learning, I can squeeze them together. But it turns out, funny enough, when I was studying machine learning, as with you guys, when you take to courses, whatever, they're gonna spend 80% on feed forward or supervised learning. It turns out that unsupervised learning is so often under neglected, and it's so useful, not only in its own analysis. You can actually use this to inform how you build your supervised learning model. So unsupervised learning is a lot more worthwhile than, in my experience, I think, than people pay attention. You open a textbook on machine learning, supervised learning is like one chapter or two. Okay, I'll see you guys on Tuesday. And okay, give yourself what? Seeing that this is the first time, don't have to worry about getting anything decent. What I want you to do is play with it and say, I tried this parameter, I tried this variable, this is what I get. Copy the screenshot, copy paste, make comment, copy paste, make comment. That's all I want. Okay, right? And turn that into your TA. Okay,ครับ.ครับผม. Yeah, no problem. Yeah. Hold on. Let me just end. I have to end the Zoom. Save. Stop share. End the meeting.